Artificial intelligence. You hear that term everywhere, right? It's in the movies we watch, it's on the news, and it's literally in the phone you're holding right now. But what is it really? Like beyond all the hype, how does it actually work? Well, in this explainer, we're going to pull back the curtain and demystify AI, starting with the biggest question of them all.
Should we be afraid? I mean, that's the question that hangs over every single conversation about AI. And you can't blame people for asking. For decades, pop culture has been feeding us these nightmares of robot overlords, Skynet from the Terminator or the machines from the Matrix. And hey, when super brilliant people like Stephen Hawking start issuing warnings, it's pretty hard not to feel at least a little bit nervous.
But here's the weird thing, the big paradox. The AI we're afraid of is this conscious, evil villain bent on world domination. But the AI we actually use every single day is in our pocket asking if we need directions to the nearest coffee shop, or it's in the background deciding which YouTube video you should watch next. One is total science fiction, the other is just Tuesday. So what's the deal? Where's the gap between the two? That is exactly what we are here to figure out.
Okay, first things first. Let's separate the science fiction from the science fact. Because if we really want to understand where AI might be going, we first have to get a super clear picture of what it actually is today.
So here's the absolute core idea. A normal computer program is, it's rigid. It just follows a script. If it hits a problem it wasn't specifically coded for, it just breaks. But an AI? It's different. It can chew through enormous amounts of data, find patterns all by itself, and then, and this is the key part, it can apply that learning to new things it's never seen before. That ability to generalize, that's its superpower.
But how does a machine actually learn? It sounds kind of like magic, doesn't it? Well, it's not. It's a process. So let's pull back the curtain and look at how the engine really works. We're going to use a really simple example to make this crystal clear.
Okay, imagine our goal is to teach an AI to do something that seems pretty simple for us. Just look at a picture and tell us if there's a bird in it. Simple, right?
So this whole process is called training. First, we give it some clues. We define the features of a bird. It has a beak, it has wings, feathers. Then we assign a weight to each one, like how important it is. Now comes the most important part. We test it. We show it a picture of, say, a penguin. The AI might get it wrong. And when we tell it, nope, that's wrong, the AI goes back and automatically adjusts its own internal numbers, its weights. It learns from that mistake. Now you do this not once, but thousands, even millions of times, with millions of images, and slowly but surely, that AI builds its own incredibly complex model for what a bird is. And this is maybe the most important thing to get your head around. The AI doesn't understand what a bird is. It has no concept of flying, or chirping, or building a nest. To the machine, a bird is just a specific cluster of numbers and patterns that match the values it has learned to connect with a label bird. It's just pattern matching, but on a mind-boggling scale.
Now, this process, this massive scale pattern matching, is unbelievably powerful. But it can also lead to some really, really weird and hidden problems. And that brings us to something called the black box problem.
Okay, so when an AI trains itself on millions of pieces of data, its internal logic, all those numbers and weights we talked about, it becomes so complicated, so tangled that it's basically a locked black box. We can see the information we put in, and we can see the answer that comes out, but we often can't see why. We don't know exactly how it got from A to B.
And here's a classic real-world example of this. Researchers trained an AI to identify wolves, but it kept making these really weird mistakes, like calling a husky a wolf. When they finally figured out a way to peek inside that black box, they found something bizarre. The AI hadn't learned what a wolf looks like at all. Nope. It had learned that pictures labeled wolf almost always had snow in the background. It wasn't a wolf detector, it was a snow detector. It found the laziest possible shortcut to get the right answer, and the humans who built it had absolutely no idea.
And this kind of thing leads us straight to another massive challenge: bias. You see, an AI is only as good or as fair as the data we trained it on. So if our data is flawed or biased, you can bet the AI's decisions will be flawed and biased too.
Take this famous case study. An AI was built to help a company screen job applications, but it started systematically throwing out applications from women. Why? Not because someone programmed it to be sexist. It was because it was trained on the company's hiring data from the past 10 years, data that already showed a clear bias toward hiring men. The AI didn't invent the bias. It just learned our bias from the data and then amplified it with scary efficiency.
So given all these limitations, like the black box problem and bias,
where does our current tech actually stand? How close are we to those self-aware machines from the movies? Well, to answer that, you have to understand the different types of AI.
Okay, pay really close attention here, because this is probably the most important distinction in this entire conversation. Everything we have today, and I mean everything, from Siri to ChatGPT to self-driving cars, is what we call narrow AI. It can be brilliant at one specific task, but it can't do anything else. Your chess-playing AI can't write you a poem. Now, the next level up is general AI. This would be an AI with the flexible, creative, problem-solving intelligence of a human. And guess what? It does not exist. It's still completely theoretical. And then, way out there, is super AI, an intellect that is smarter than any human in every way. And that's firmly in the realm of speculation.
So, when people talk about that sci-fi nightmare of AI taking over, what they're really talking about is a future, hypothetical super AI. The worry is that it could start improving itself so fast that its intelligence would just explode in what's called a technological singularity, leaving humanity way, way behind. But again, that is not the technology we are dealing with today.
So, let's bring this whole conversation back down to Earth. Instead of worrying about a Terminator in the distant future, what are the real challenges we're facing with the AI that exists right here, right now?
And this is where the conversation is really starting to shift. The fear of a machine waking up and becoming conscious is, honestly, becoming a distraction from a much more immediate and real risk. AI is an incredibly powerful tool, and just like any tool, whether it's a hammer or the internet, its real danger isn't that it's going to develop a mind of its own. The real danger is how we, as people, choose to use it.
So what should we actually be watching out for? Well, things like people using AI to create deepfakes and commit fraud, or the subtle ways that algorithms can be used to shape public opinion without us even realizing it's happening. And of course, the very real, very urgent need for all of us to adapt how AI is going to change jobs in the economy. These are the conversations we need to be having right now.
And that really brings us to our final thought for today. The fear is always framed as AI is going to take my job. But maybe a much better way to think about it is this. AI won't take your job, but a person who knows how to use AI might. It's a tool, and the person who learns how to use that tool best is going to have a massive advantage. So the real question isn't whether we should be afraid of the machine, it's whether we're ready to learn how to work alongside it. Are you?